The following content is created by DrAvitech. Your support and donation will help me continue to offer high-quality educational resources for free. To make a donation, send an email to 6drcyril@gmail.com or comment donations below. Welcome guys, I'm DrAvitech, and in this video, we're going to be solving this very problem on half range. So remember, in the previous video, I've explained what this is. So since we're asked to find the half range sine series, we're going to be treating that function as an odd function that only has the sine terms. So as an odd function, we only need to find b sub n. So b sub n is 1 over pi integral from 0, since we're dealing with half range, this will be 2 and then this. So if you're taking the half of the range, you have to double this part. And then we'll have f of x sine nx dx. So this is what b sub n would be. That's the formula for b sub n. So this will be 2 over pi, integral from 0 to pi. Now f of x is 4x. So this is 4x sine nx dx. All right. Now the 4 is a constant. So this 4 can come outside to mean 2. So when it does that, it makes it 8. So this will become 8 over pi. Then we have the integral from 0 to pi of x sine nx dx. So that's what we have. Now this is the part we now use integration by parts. So this will be 8 over pi, 8 over pi. Now if you integrate this function, so I want to use the short form. So I'm going to write x. Differentiate x, you're going to get 1. So I'll write my x, then I'll differentiate the x to get 1. If I differentiate 1, I'm going to get 0. So there's really no need for that. Now this sine nx, I'm going to be integrating it. So if you integrate sine, you get minus cos nx. Now this minus cos nx, you have to now remember to differentiate the angle nx. So when you differentiate nx, you're going to get n. So you must divide by n. Now this very bracket you see, this very bracket here, you need to do what? You need to integrate it again because there's a number here. So you need to integrate this again. So open up a bracket, put in your minus. When you integrate cos, you will get sine nx over, when you differentiate the ns, you will get n. That n will come and times this very n here. So now make it n squared. So this is what we now have. Now this will be plus and this will be minus. And then our interval is 0 to pi. Now whenever my interval is 0 to pi and I see sine, I don't waste time. I'll just go and cancel it. Whenever my interval is 0 to pi, even if it's 2 pi, whenever my interval is within that minus pi, 0, pi, 2 pi, and I see sine nx, I'll just know that it's 0. Because sine n pi is equal to 0. Sine 0 is still 0. Sine of minus n pi is 0. Sine of 2n pi is 0. Like, it's just 0. So I don't really stress myself with that. So this will be 8 over pi. Now, this is minus, this is plus. So this will be minus x cos nx all over n from 0 to pi. All right. Now this n is a constant, so just bring it outside. So this will be 8 over n pi. It's coming outside to the denominator. The minus 2, let it still come outside. So this will be s cos nx from 0 to pi. All right, so that's what we have. Now this will become minus 8 over n pi, minus 8 over n pi. Now anywhere we see x, we'll be putting pi. So let's put pi. So this will be pi cos n pi minus, anywhere we see x the second time, we're going to put 0. So this will be 0 cos 0. So that's what we have. Now, this will be minus 8 over n pi times, this part of 0 cos 0 is basically 0. Because 0 times anything is that same. 0 times anything is 0. So that guy is gone. And then we have pi cos n pi. So this pi we cancel out this pi. So this is minus 8 cos n pi has a special value of minus 1 to the power of n, and then divided by this very n you see. So now my f of x will then become the sum from n equal to 1 to infinity of b sub n sine nx. So this will be the sum from n equal to 1 to infinity. Now this b sub n is minus 8 into minus 1 to the power of n over n sine nx. That's what we have. Okay. Now the minus 8 is a constant, so you can just bring it out. So this is minus 8. Yeah, minus 8. Sum from n equal to 1 to infinity. What will be left is minus 1 to the power of n over n sine nx. All right. Now at this point, this is actually your answer. This is actually your answer in terms of n. But you might want to expand. So this is minus 8. Then let's open up a bracket. Anywhere we see n, let's give it 1. So minus 1 to the power of 1 is minus 1. All over 1 is still minus 1. Then sine 1x. So this will just be minus sine x. Basically, that's what it's just going to be. Basically. Okay. And then the next part of this is 2. Minus 1 raised to the power of 2 will give us plus 1. So this is plus 1 over 2 sine 2x. Next will be 3, so that will be negative. Minus 1 over 3. As you can see, I'm not doing it very fast because I kind of know what this will be. Minus 1 raised to the power of 3 will be minus 1. Then all over your n is 3, then sine 3x. Then if it's 4, this will be plus 1 over 4 sine 4x. And just like that. So with this, that would just be all for this very video. This is how to solve this very problem. I'll see you in the next one.